This lesson is you're doing. Yesterday we did going from quadratics to square roots. Today we're going from square roots to quadratics. Okay. So you still switch the variables and they resolve. So that means solve for y. And when inverting the square root, you get a quadratic. So, but only don't forget you can only use half of it. Okay. So for example, you have to be able to restrict the domain of quadratics when you find the inverse, which is the square root. So this means x is less than h. So this one tells you that we can only use the right side of a quadratic. Okay. And if it's x greater than h or equal to h, then in this case we can only use the right side. So don't forget you have this on the notes from yesterday or the previous lesson. So real quick, let's do some practice. So for example, number 1, we want the left side. So that means we have to say x is less than or equal to, this goes from 0 because the value of h is 0. Okay, I mean that h right there. There is no left or right because there is no parentheses. So we go from 0. So that means the left side. For this one, plus 4, that means, don't forget, it's the opposite of what you think. You see plus 4, some of you think it's right side, but actually you're going to the left 4. So for this one, we want the left side. So that means x has to be less than or equal to negative 4. Okay, and example number 3. For this one, we go to the right 8. So then all the values, since we're only using the left side of the graph, we can use all the values less than or equal to 8. So that's just a quick reminder on how to restrict the domain on quadratics when you find the inverse, which is a square root. So what about the right side? For the right side, so for this one, we have to say in this case there is no left or right because there is no parentheses. So then x is greater than or equal to 0. Okay, that's the first example. The second example, this goes to the right 9. So then all the values of x that are greater than or equal to 9. And the last example has a plus 5 inside. So then that means go to the left 5. So we're going from all the values that are greater than or equal to negative 5. So again, this helps you use the right side of the parabola. Okay, and this one here helps you use the left side. So keep that in mind when we find the inverse. So with that said, let's go to example number 1. Let's find the inverse. Restrict the domain of your answers. You won't be bringing in the radical, so there's no absolute value. So don't worry about plus or minus today. So notice this one, we have the square root, right? So what we want to do is we want to switch the x and the y. So then switching x and y, this is now x, and this is equal to the square root of y plus 3. Again, we want to get the square root of y by itself for now. So let's subtract that 3 from both sides of the equation. So minus 3 on both sides. So then this becomes, the left side becomes x minus 3 is equal to the square root of y. But now we don't want square root of y, we want y by itself, so we take the square. So I'm going to take the square of the square root of y, and I'm going to take the square of x minus 3. So then once we take the square, we have x minus 3 square is equal to y. But then since we're restricting the domain, okay, so I'm going to restrict the domain in a moment. So I'm going to write this in function notation. So f inverse of f of x is equal to x minus 3 square. And notice, this was the positive square root. So that means I can only use the right side of the parabola. So then I have to say x is greater than or equal to, this goes from 3, so greater than or equal to 3. So this is the inverse, and this is the domain. The point is, we cannot use the whole graph, because if we do, then the inverse is not a function. With example number 2, notice there's a negative inside of the radical. Outside of the radical, so that means we can only use the left side of the parabola. So we'll come back to this in a moment. So again, process the same. Switch the x and the y. So x equals the negative square root of y plus 8. Now, here we want this to be positive, so let's divide by a negative 1 on both sides of the equation. So then the x becomes negative x, and now this becomes positive square root of y plus 8. So then once we have the radical isolated, let's take the square. So take the square of this side and take the square of negative x. So the negative x becomes positive because you're multiplying a negative times a negative. So this is positive x squared, and this is y plus 8. Okay, then from here, I want to get the y by itself. There's a plus 8. I'm going to subtract that 8 from both sides. So then the equation is now x squared minus 8 is equal to y. So this, if I leave it like this is not an inverse because I'm not restricting the domain. So I'm going to switch this to function notation. And I'm going to say f inverse of f of x is equal to x squared minus 8. But then I have to look at the fact that I'm given the negative square root. So this tells me that I can only use the left side. There's no parentheses here, so that means we're going from 0. So that means all the x values that are less than or equal to 0. So that's a restriction on the domain for this problem. Last example, example number 3. For this one, I'm going to switch the x and the y. That's the first step. So x equals the square root of y minus 7. As you can see, the radical is isolated, so then we can proceed to take the square, so we can cancel the square root. So I'm going to take the square of this side and also take the square of this radical. So then this becomes x squared is equal to y minus 7. We want the y by itself. Let's add that 7 to both sides of the equation. So then this side becomes x squared plus 7, and now we have the y by itself. Okay, so again, I'm going to write the inverse using the inverse notation. So the inverse notation is the following: f inverse of x is equal to x squared plus 7. But I need to restrict the values of x. So then my restriction is going to be, I look at this equation. This is the positive square root of x minus 7. So that means I can only use the right side of the quadratic. So the restriction of the domain is x greater than or equal to. This goes from 0 because, again, there is no parentheses. So that means h is 0. And this is the answer to that problem. Okay.